Good evening, students. Welcome to one more session of your WOC. This is your Vani ma'am back again with MCQ series term 1 on solutions chapter. So basically, this is your second unit of your physical chemistry. Correct, students? So you all know we have your term 1 MCQs. As I promised, I have already done MCQs on solid state. Yes, I have done MCQs on solid state. Please check the video. This is already done. This is for term 1. Right. I have done MCQs on haloalkanes and haloarenes. This also is done perfectly. You can also watch that which is kept in the playlist. Okay? So today we are going to learn about the solutions MCQs. Shall we start off, students? So remember, always keep working hard. You'll be the best. All right. So one concept you should always remember, you are the best students. Only thing is do hard work. If you do hard work and also smart work, hard work always doesn't work. Hard work and smart work, if these two things work together, you are always the best. All right. So keep working hard. Vani ma'am is always with you all. WOC is always with you all. So keep sharing the videos and important thing, believe in yourself. I always believe in myself. I think I'm the best always. Yes. So all the best. Let us start off with the session, students. Yes. So the first question, let me once check whether it is recording or not so that I can just check. Yes, it is recording. All right. Let's start off with the session. Question number 1 of your solutions chapter. Let us read the question. The concentration of a solution is defined as what? So normally, students, concentration means what? See this beaker. All right. This beaker has both the solute particles, red color ones, and the solvent particles which are there in the form of blue color. Yes. So both pink and red, both are solute particles. So what is happening? Concentration means the amount of the solute particles. You are able to see solute particles are red, white, solute particles red, white. You're able to see more of the solute particles, correct? So if the solute particles is more, then I call it as a concentrated solution. Here, in a dilute solution, water is maximum or water particles is water is more. That is your solvent is more and the solute particles have become less. You're able to see your solute particle and this is solute particle very, sorry, not this one, the black color one. So the solute particles have become less. So what is it, students? What did they ask? The concentration of the solution is defined as what? It is nothing but the amount of solute present in the given amount of solution. Easy question. Option B is the correct answer. So concentrated solution means solute particles are more. It is thick in nature. Let us see the next question. So if N represents the number of moles of a solute and capital N represents the number of moles of the solvent, the mole fraction of the solvent is given by what? All right. Simple question. What did they say? Mole fraction they are asking you. So what is it, students? Basically, now mole fraction is always denoted by, yes, it's denoted by X. You can take it as X, which depends upon N by number of moles of the solvent. If I have to take and small n, it is number of moles of the solute plus number of moles of the solvent. Yes, so it depends. If you they say it represents the number of moles of solute. They said so here they have already given n represents number of moles of solvent and n small n represents solute. So you can take the formula as number of moles of the solvent divided by number of moles of the solute. So option uh, B is the correct one. Correct now, students? Yes. Suppose if they ask you solute, then you would take this. If they ask you solvent, you can take this. Yes. They have asked me here mole fraction of the solvent. No, that's why I have taken the second formula. Easy. Next question. Let's see. Molarity. Okay. Molarity is defined as a number of moles of solute present in. Molarity formula is M is equal to moles of solute divided by volume of solution in liters. Correct? Volume of solution in liters. This is what is your this one. All right. What did they ask me? Molarity. M is equal to N by V. Now check students. It is defined as what? Where is it? Volume of the solution in liters. See here. 1 liter of the solution. Perfect. Easy. Option B. Next thing. Let us see one more. The molality of a solution is defined as number of moles of solute present in. Okay. Molality is denoted by small l. What is the formula? Moles of solute. Formulas are given in the form of MCQ students, divided by kg of solvent. The solvent is measured in kg. Correct? So what is it now? Molarity is moles of solute by kg. Here already moles of solute is given. What is left out now? Kg. Denominator is here. 1 kg of solvent. Easy? All right. Now let us go to the next question. Normality. Normality of a solution is a number of dash of solute per liter of the solution. Basically, normality is denoted by capital N. What is the formula? Normality is equal to gram equivalents of solute divided by volume of solution in liter. Volume of solution in liter. Correct, no students? This is the formula. If I have to write further, gram equivalent weight is what? Weight by equivalent weight into 1000 by V in ml. This is the formula. So what is equivalent weight formula, students? Equivalent weight formula is molar mass by N. These are all the formulas of normality. Now you only check which is the option. The normality of a solution is the number of dash of solute. See here, normality of the solution is number of dash of solute means equivalence of solute. Easy? Yes. So remember this formula, MCQ is easy. Next question. The weight percentage of a solute in a solution is given by, yes students, weight percentage is nothing but small w by capital W into percentage. What is it equal to? It is equal to nothing but weight of the solute by weight of the solution into 100. This is the option. So it's a direct formula. So I have marked that. Don't get confused. Solute is always in the numerator. Remember. And solution, this solution contains solute plus solvent and into percentage into 100. Easy? All right. Next thing. Solubility generally rises with, yes students, solubility rises. Now observe two graphs here. When you have a solid in a solid into the solvent, so basically solvent is the maximum quantity. In that you're dissolving a solid. Here in this case, gas is a solute. You're dissolving it in the solvent. Solvent is maximum. So always remember students, when you are dissolving solid into a solvent, observe as the temperature is increasing, solubility also increases. Dekho, temperature is increasing. Yes, even your solubility also increases. Remember. So for solid solute, as the temperature increases, solubility also increases. So mark the option increase with temperature. But in case of gases, it is reverse. For a gas, as the temperature increases, solubility is decreasing. See, it has become minimum. Minimum. Temperature is maximum. If the temperature is maximum, observe. If the temperature is maximum means solubility is minimum. So it is reverse. So remember, solid solubility into solvent always it increases with temperature. Solubility increases with temperature. Suppose if you have gas in a solvent, it remember solubility decreases with temperature. Remember this. Okay? Next question, students. Which of the following characteristic or which of the following concentration effect is affected by change in temperature? Okay? Which of the following concentration is affected by change in temperature? All right. The answer is A. Why? Because molarity is equal to weight of solute in grams. This is the formula divided by molar mass into volume in liter. Correct, my students? Okay. Now you only tell me molarity is a concentration factor. Here you have volume. We very well know according to Charles' law, volume is directly related to temperature. That means molarity is temperature dependent. Correct, my students? See here. Which of the following concentration factor is affected by change in temperature? It's nothing but molarity, because you have concentration in the concentration formula, volume. So volume is dependent upon temperature. So molarity. Let us see the next question. In a mixture of A and B, components show negative deviation. Right. So basically, negative deviation concept. There are two types of deviations. What are they? One is positive deviation, one is negative deviation. So when negative deviation arises, so this is your negative deviation graph. Okay. Showing positive deviation also is there. Okay. So here this is positive deviation. Basically, this is positive deviation graph, students. Sorry for the thing. So this is positive. Your negative will come below like this. Negative will come below like this. So negative, the Raoult's law, this will come below. So this is the ideal gas, ideal solution, the negative. So all the dotted lines, whatever are there, all the dotted lines are showing negative deviations. Okay, negative deviations. So this should be negative deviation graph which I have drawn. Okay, now observe carefully. When does this happen? Now you have a solute. Observe carefully. AA. Okay, here the bond is very strong. Let us assume one more solute, BB. Okay, these two are solutes. Okay. Now A and B are combining. Now what happened? Solute. This is solute. This is one solute. This is solvent. Let us take BB as solvent. Okay. Now A and B, solute and solvent are mixed up. Now tell me, students, when will it have negative deviation? Right? If AB interactions, if these interactions are stronger, suppose if this interaction is strong, new bond has formed, this is stronger than these two, what will happen? It will not vaporize faster. Correct? It will not go into the vapor phase. Then automatically, when it doesn't go into the vapor phase faster, it will become very less. Like it will show below the ideal equation. So this is your Raoult's law. The vapor pressure will be below that. Why? Because AB interactions are stronger. Option A is correct. So for negative deviation, remember this, AB interactions are stronger than AA and BB. Okay? Remember this. Solute solvent interactions are greater for that. Okay. Next question. When a saturated solution of sodium chloride is heated in, so already the solution is saturated. Which one? Sodium chloride is saturated. What will happen? You're heating it. Suppose saturated solution means no more solute you can add. Right? You can't add any more solute. Now what will happen, students? You're adding, you started heating your saturated solution, you're heating it. This you started heating it. So what will happen? What will happen, students? What did I say? Sodium chloride is a solid. Okay. Yes. When in a solid is there in a solvent, you're increasing the temperature. When the temperature is increased, what will happen, students? I said solubility increases. Right? I showed you just now a graph. Solubility increases. Okay. When the solubility increases, more and more salt starts adding to this. More and more salt adds to this. Yes. When more and more salt adds to this, what will happen, students? It will become, means you're adding, it is dissolving. You're adding, it will dissolve. So further, no more solute can add to this. Over means you're adding. So here the solution, you're adding and adding more, you're dissolving, because solubility increases with temperature, no? So when you start increasing, it will become which type of solution, students? It becomes unsaturated. Why? Concept is this: for solid, solubility increases with temperature. So from saturated solution, it turns into unsaturated solution. So more and more dissolves. See? Okay. Next question. In liquid CCl4, which of the following has maximum solubility? All right, easy. Basically, when I see among all these, the option is B. Why? Bromine is a liquid. Okay, compared to this, bromine is a liquid. So when it is a liquid, it is more soluble, right? More soluble compared to chlorine or iodine. Is it okay? So option. So liquid carbon tetrachloride maximum solubility, which will be there when you add bromine to that. Okay, right. Next question. When non-zero volatile solute is dissolved in a solvent, the relative lowering of vapor pressure is equal to which one? Okay. So non-zero volatile solute. First of all, RLVP, relative lowering of vapor pressure, RLVP. What is the formula? It is P naught A minus PA by P naught A, which is equal to XB. Correct? Or you can write the same thing as delta P by P naught PA is equal to XB as N by small n by capital N, number of moles of solute. This is mole fraction of solute. Correct, now students? This is the formula. This is what? Number of moles of solute. This is number of moles of solvent. Correct, my students? Yes. Now, observe carefully. What did they ask? When non-zero volatile solute is dissolved in a solvent. Okay, now I said, relative lowering of vapor pressure is directly proportional to the mole fraction of solute. Yes, non-zero volatile means compulsory the solute is there down. It will, like, no, it's not volatile, it is non-zero volatile. So compulsory the relative lowering of vapor pressure depends upon the mole fraction of the solute. Yes, according to this formula. Next question. When the solute is present in trace quantities, the following expression is used. So trace quantities means less, very less quantities, very, very, very less quantity. Okay, very less quantity the solute is present. So what is that? You have different parameters here. So remember, students, whenever solute is present in very less quantity means it's nothing but ppm. Remember, ppm is equal to 10 raised to power of 6. ppb is equal to 10 raised to power of 9. PPT is equal to 10 raised to power of 1, 2, 3, 4, 5, 6, 7, 8, 10. Yes, when they say per milli, it is equal to 1 into, it's like this. Okay, percentage, if they say percentage, what do? You multiply with 100, 1 into 100, like that. Yes. So if the solute is in very less quantity, it is nothing but parts per million. ppm. Okay, done. Now let us see the next question. The molecular weight of benzoic acid in benzene as determined by depression in freezing point method corresponds to what? Right. When they give you benzoic acid, first important thing, draw the structure and see. This is your benzoic acid. Correct? This is your benzoic acid. Now hydrogen is there. This hydrogen starts bonding, forming a bond with one more oxygen. So this is your hydrogen bonding. Yes, this is linked to carbon. This is linked to C6H5. Now this is oxygen. This is hydrogen. And again there is an hydrogen bonding. This one. Now observe carefully, students. Benzoic acid always undergoes what? Yes, due to this hydrogen bonding, it undergoes dimerization. Yes. Now observe the molecular weight of benzoic acid in benzene as determined by depression in freezing point method corresponds to dimerization of benzene. Yes, easy. We very well know. Colligative property depends upon the number of solute particles, not on nature. Correct? Yes, colligative property depends upon number of solute particles. So solute particles are double now. That's why It depends upon dimerization. So colligative properties will never depend upon nature. They will depend upon solute. Next, which of the following is correct for positive deviations? We saw one negative deviations. I said something, no? Yes, for positive deviation, always remember, careful. These, see, two things you have to remember. Point number one, AB interactions will be less than AABB. This is point number one. Second important thing, students. Positive deviation or negative deviation are shown by non-ideal solutions. Correct, no? Yes. This is ideal solution. This is non-ideal solution. This is non. Thick lines are all non-ideal solutions. So non-ideal solutions, what will happen, students? Delta H value will be positive. Delta V value will be positive for positive deviation because it is positive. If it is negative deviation, it will be negative. Both will be negative. Okay. So which is the option which is right? Delta H is positive, delta V is negative. Because it is positive deviation, it is above the graph. Okay. Next question comes. The solubility of a gas in a liquid increases with what? I said something. For a gas, if you observe, see here, the temperature was here. Now the temperature is increasing. When the temperature was maximum, yes, what happened to the solubility, students? See here, see here, see this. Exactly the same point. Observe. What happened? Remember, for a gas, solubility of a gas, of a gas in liquid, of a gas in liquid, remember, decreases with temperature. You're able to see the graph. So solubility is inversely related to temperature increase or decrease, in which case, in case of gas in solvent. Remember that. Okay, students, remember this. Clear? All right. So what is the temperature? What is the thing? Decreases in temperature. For solid, it increases. For gas, it is decreases. Okay, let us see some sum now. A molal solution of sodium chloride has density of 1.21 gram per milliliter. Okay. The molarity of the solution is what? Easy. This is a easy sum. Let's see. What did they give me? 1 molal NaCl solution. This is what they said is equal to how much? How much is 1 molar solution? It's nothing but 1 mole NaCl in 1000 grams of water. 1000 grams of water. This is what is the thing. Correct. Now, how much is the molecular weight of this? 58.5 grams plus 1000 grams solution. So, yeah, how much is this? 1000 plus 58 is 1058.5 grams. Okay, done. This is a solution. Okay, now observe. So, what did they say? Molarity of the solution. This. What is molarity of the solution? Capital M is equal to number of moles of the solute, 1058.5, divided by density. Why did I take this? Okay, now observe. So basically, molarity is number of moles of solute by volume of the solution. Correct. What is volume of the solution? Density is equal to mass by volume. Correct. So volume and density are inversely related. Fine. So what did I do? I have taken, instead of volume, I have taken the density down and I this out. So density I have multiplied down, which comes approximately to around 875 ml. Okay. Now I have not completed this. Now I need to complete it. So molarity, now I'll calculate using this. So I'm going to write this part here. Observe. So what is molarity, students? Molarity is equal to capital M. Molarity is equal to 1 molar solution 1 divided by 875 into your 1000 per liter. Correct? How much it comes to? 1.143. This is your molarity. So what is the option now? Option is easy, students, easy. So I just took the density concept, I just divided it. I took the molarity formula for 1 molar solution and I did it. Next question. At room temperature, the mole fraction of a solute is 0.25 and the vapor pressure of a solvent is 0.80 atmosphere. The lowering of vapor pressure is how much? Directly write the formula. P naught by P naught is equal to X grams of solute. Done. Now, how much is P naught, students? What is P naught? I don't know. Right? So, do I know? Do I know? Do I know P naught? Okay. So, relative lowering of vapor pressure has asked. So, I don't know P naught minus PS. Relative lowering of vapor pressure, I don't know. Now, substitute. I know what? I know mole fraction of solute. So, P naught minus PS divided by P naught, do I know? Yes. Vapor pressure of the solvent is there. P naught is there. P naught is 80 is equal to 0.25. So if I solve this P naught minus PS, if I cross multiply this and do, how much do I get? I get P naught minus PS is equal to 0.25 into 0.80, which comes to 0.20 atmospheres. That's all. I got the answer 0.20. This is the correct answer. Easy? Yes, students? All right. Now, let's see the next question. One more numerical. The rise in the boiling point of a solution containing 1.8 grams of glucose in 100 grams of solvent is zero point 0.1 degree. The molal elevation constant of the liquid is what? Okay, easy. Molal elevation constant formula is what, students? Basically, TB is equal to KB into M. This is your molal elevation constant. I have to find Kb. Let us take out Kb is equal to delta Tb by M. Okay. M is what? Molality. Now, molality formula is what? Number of moles of solute by weight of the solvent. Correct? Okay. What is number of moles of solute? 1.8 grams. 1.8. Okay. 1.8 grams. Number of moles is nothing but weight by molecular weight. What is the molecular weight of glucose? 180 grams. Divided by how much is the weight of the solvent? 100 grams. How much it comes to? Okay, 100 into 1000. How much it comes to? 0.1. Okay. Now substitute molarity value here. Kb is equal to delta Tb. How much is given, students? Did they give me Tb? 0.1 degree. So 0.1 by 0.1 is nothing but Kb is equal to 1. 1 K by M. Easy? Yes. Yes. One time it goes. So what is the answer, students? It is 1 K by. Easy? Okay. Let us see one more. In a 0.2 molal aqueous solution of a weak acid, HX, the degree of ionization is 0.3, taking Kf for water as 1.85 kg kilomelt. The freezing point of the solution will be nearest. Okay, they asked me to find out delta Tf. What is the formula? Molality into Kf into I. Why? Because Van 't factor is always added as a correction factor. Correct? Now, how much is the molality given to me? Yes. How much is given? 0.2 molal solution. Observe. How much is the Kf given to me? 1.85. How much is I factor, degree of ionization given to me? It is 0.3. Yes. So here basically the degree of ionization 0.3 for 1 and one more hydrogen is there, so 1.3. Done. How much do I get? When I multiply 0.2, it'll come around 4.481 degrees centigrade. So freezing point is how much, students? Freezing point temperature is how much? It's less, no. Freezing temperature is less, so it is minus 0.481 degrees centigrade. Where is the answer? Where is the answer? It is minus 0.481. Easy. Let me drink some water. All right, next question. One more question on osmotic pressure. What do they give me? Osmotic pressure of a solution is 0.0821 atmospheres at a temperature of 300 Kelvin. The concentration in moles per liter will be, okay. Osmotic pressure formula is pi is equal to CRT. Okay. What should I find? Concentration. C is equal to pi by RT. Done. Now, what is pi, students? What is pi? Pi value is 0.0821. What is R value? How much is given to you? R value given to you. Gas constant value, you know, it is nothing but. So, all right, it is again 0.0821. What is the temperature value? 300 Kelvin. 300. Multiply karo. So, when you multiply all these, you get an answer around zero point 0.3. Okay, 0.3 in 10 raised to the power of -2 mole per liter. This is what you get. So, simple option. This is option. Easy. Okay, next question. I did all the numericals based on your colligative properties. Check. A solution containing components A and B follows Raoult's law. Okay, they follow Raoult's law. So, if they follow Raoult's law, which is the option? Remember, whenever a solution obeys Raoult's law, okay, if it obeys Raoult's law, what should you remember, students? Raoults. Okay, Raoult's law. What should you remember? All interactions are same, because Raoult's law, if it obeys, means it is an ideal solution. For an ideal solution, all interactions are same. So what interactions are same? AB interactions will approximately be equal to AA and AA or BB. All right. Now check, students. Check which is the option. AB is force is greater. No. AB force is less. No. AB is remaining the same. Right. All right. Easy. Next question. Which of the following statements is false? Which of the following statements is false? They're asking. Okay. Let's check. Raoult's law states that vapor pressure of the component of the solution is proportional to its mole fraction. Perfect. It's right. Next. Two sucrose solutions of the same molality prepared in different solvents will have the same freezing point depression. Oh, this is a little bit wrong. Let's see why. Because two sucrose solutions of same molality, they said. Of same molality, they said. Okay. Same molality means, according to this, freezing point. Observe carefully, students. They will have same freezing point. Molality is same means freezing point also will be same. Why? Freezing point is same. Why? Because we have the formula delta TF is equal to KF into M. This is the formula according to depression and freezing point. Observe. Because freezing point does not depend upon the nature of the solvent. Correct? Freezing point, it's a colligative property. It will not depend upon the nature. For me, important thing is number of moles of the solute. So they said two sucrose solutions will have different solvents. I don't know. Solvent, it will not depend. Correct? So always remember colligative properties does not depend on nature of solvent. So they are saying here, they are saying two sucrose solutions are prepared in different solvents, is it? That's why this option is a wrong option. This is the answer. So the correct answer for this is this. So because it depends upon different solute have same freezing point, they said wrong. No, colligative property does not depend upon solvent. All right. So they have related solvents and freezing point. That's why this is wrong. Okay. Next question. Equimolar solutions in the same solvent have. Equimolar solutions means what, students? Equimolar means colligative properties. All right, like freezing point, colligative properties like boiling point. Yes, all will be same. Yes, why? Because equimolar solutions means, so basically students, colligative properties depend upon number of solute particles. Remember this one. So you only tell me here. Equimolar solutions means same boiling point and same. Yes, they will not depend upon the solute. Not equimolar means molar concentration of the solute is same. So delta TB and delta DB TF will be same. Okay. All right. Next one. Very important. Which of the following liquid pairs show positive deviation from Raoult's law? Okay. See here. They have given these options. I'm marking this as D. Why? See here. This and this is benzene. Okay. This is AA. Okay. This is methanol. Hydrogen bonding. Hydrogen bonding. This is BB. Okay. Now see. Here, what happens? AA interactions and BB interactions when I check. Yes, students. Benzene and methanol interactions, right? Check. Here, in this case, AA and BB interactions are stronger than AB interactions. Why? Why? Because there is no hydrogen bonding in them. Correct? This and this can't bond. A is this, B is this. So there's no hydrogen bonding. That's why, but individually these two bonds are stronger. When these two bonds are stronger, will it evaporate immediately? Will it go to the vapor phase immediately? No. It will take lot of time to evaporate. That's why the vapor pressure is maximum. It is maximum. Here the vapor pressure is maximum. Here the vapor pressure is maximum. Because these two interactions separately or maximum, it will be more than individual. Okay. All right. So option is that. Next one. There's one numerical. Let us solve that. Benzene and toluene form nearly ideal solutions. At 20 degrees, the vapor pressure of benzene is 75 torr and that of toluene is 22 torr. The partial vapor pressure of benzene at 20 degrees for a solution containing 78 grams of benzene and 46 grams of toluene in torr. Explain. Okay, what should I find out? I have to find out the partial vapor pressure. What is the formula? PB is equal to into XB. Okay. What is P not B here? Basically, they said they asked me to find partial vapor pressure of benzene at 20 degrees. I have to find, yes, containing 78 grams of this. So here what happened? P not B is the solute part. That how much is given? That's benzene 75 torr. Correct? So how much is this? 75 into XB. XB number of moles of the solute. Right? How much is this? 1 divided by how much did they give me? Right, solute did they give me? Okay. So if I find separately for benzene and toluene, separately if I calculate for benzene weight by molecular weight, weight by molecular weight and divide, I get 1.5. I'm directly doing it here. So when I take 1.5 and 75, it comes to 50 torr. So I did directly here, students, taking into the mole fraction of the, so this one, of the solute and the solvent. So what is the answer? 50 torr is the answer. Easy? Okay. Let us see the next question. Next question. Glucose C6H12O6. Do I have a page? Okay, I don't have a page. I'll do it here. Glucose formula is this. It is added to 178.2 grams of water. The vapor pressure of this particular water for the aqueous solution is 100 grams. Okay, right? What did they ask me? The pressure of the aqueous solution at 100 degrees. What is the vapor pressure at 100 degrees is what they're asking. Let us see. What is the formula? P naught minus PS by P naught PS is equal to N moles of solute divided by N moles of solvent. This is a formula. Alright. Now, let us find for solute. N solute is equal to weight by molecular weight, 180. N of solvent. N of solvent is how much? 178.2 grams divided by molecular weight of water, 18. Okay, right. I got this basic data. Fine. Now let us substitute these values here, students. Let us substitute these values. How much is this? P naught S is how much? 760. Correct? Because 760 mm atmospheric pressure is what they have given. Correct? No, because the glucose molecule, 18 grams of glucose, because 1 atmospheric pressure they said. So 760 mm initial 0 by PS by PS. Solute is how much? 18 by 180. What is the solvent? 178 by 2 by 8. So if I divide all these, I'll be getting 0.1 by 9.9. Okay. Now solve it. 760 minus PS is equal to, yes, so 0.1 by 0.99. If I divide, I'll get it as, alright, 1 by 99 into PS. Yes, so cross multiply this. PS is equal to 760 into 99 minus PS into 99. Correct? Alright. So when I 760 into 99 minus PS into 99. Okay, this is equal to PS. So PS is equal to how much do I get, students? So divide it. 760 into 99 by 100. So how much do I get? I'm going to get an answer of around 752.4 mm. Okay, so this is the answer for yes. All right. So what is the answer, students? I've got an answer of 752.4 mm of mercury. All right. So where is our answer here? This is D. Easy. All right. Let's see the next question. When two non-reacting gases are mixed, dash is obtained. All right. Two non-reacting gases they have given me. What will happen, students? Non-reacting gases means nothing but homogeneous mixed, equal concentration mixed. Easy. Next, rate of crystallization is the rate at which. All right. Now, what is crystallization? When, see, you're taking a beaker, you're heating it. Automatically, what will happen? All the solute particles will settle on the dish. Finally, when you dry it, all your solute particles will crystallize here. Correct? Crystallize here. Yes. So, rate of crystallization what is it? The solute particles return to the crystal surface and are deposited there. Option is this. Yes, students. All right. Let us see the next question. A very big diagram is given to us. Let's see the osmosis question. Okay. Consider the following figure 2.1, okay, and mark the correct option. So you have a beaker. On one side there's a piston and you have fresh water. On the other side you have a piston again and you have solute. Sodium chloride is a solute. Now what will happen? Observe carefully, students. Which one is the correct option? So what happens? You are applying pressure on this side, this side. So when you're applying pressure to that side, what will happen? Like this. The pressure is on the salt water side. Then what will happen? You're pushing the salt water to enter it from this side to this side. Correct? The particular solute particle, they move from the solute side to the through the membrane to the fresh water. So osmosis, reverse osmosis is happening. Isn't it, students? What is happening? Reverse osmosis is happening because you're applying pressure in this direction. Correct? So what is it? So what will happen, students? What will happen? Water will move from the side B to the side A if pressure greater than the atmospheric pressure is applied on the piston. Correct? We'll move from side B to side A if the pressure more than that. If it is applied more than that, more than the pressure, then this starts moving. Yes. So what will happen? Reverse osmosis is happening. So the option 2 will be the correct option which we are okay. Easy. So nothing. It starts moving in this direction. Yes. So reverse osmosis will occur as you have seen this. All right. So this is from my end, students. Every question detailed explanation is given. So every question detailed explanation is given. I will come back with next question, next chapter. One more chapter I'll be doing detailed explanation. So please share the video. It takes a lot of pain to make a video, students. Yes, everything is free for you all. Please share the video. I'll be again coming up with the next chapter, alcohols, phenols, and ethers for you all. Yes. So in every question, along with concepts, along with numericals are explained. Correct? So please share the video. The video is for free. So WOC always believes in quality education, quality and free education. Thank you so much, students. Please share the video. Thank you.